All right, so in this question, back in 2014, the question's not really stated properly of what you're looking for, but you have this set -4 to 4, which is a subset of Z, which is all the integers, positive, negative, and 0. It's defined on A for all Mn. In A, M relates to N, a relation of some sort. Are you looking for symmetric, transitive, reflexive, or an equivalence relation? So this is the same. I found this solution here. This is the same exact question as R's Mn, and in this case, they're going to do reflexive, symmetric, and transitive to find out if it's an equivalence relation, which it would have to meet all three of those in order to be an equivalence relation. So if you go to the book, which is very important to go to the book, because if you're not looking at the book, you're not going to be able to pass these courses. So equivalence relations, you got a definition. Whenever you're doing these things, you need to write these definitions out before you solve the problem. That'll guarantee you like half credit on the question. Then you just go through the mechanics of it, and if you don't do that, great, you'll still pass the class, or at least the question or whatever. So an equivalence relation is going to be symmetric, reflexive, and transitive. So most of these are pretty straightforward stuff. It's not difficult. You just have to know the definitions, and if you're not reading the book and reading the definitions, you're going to be in trouble. So for reflexive, the reflexive case is just when X is a relation with X here, and in your case you have M and N. So you just take M or N and you plug it in, you get 0. And since 0 is divisible by 5, it is reflexive. And you can notate that down here. You see that 5 bar 0. That implies 0 is divisible by 5. This notation in this course, when you see the bar, where'd that go in the question? Yeah, when you see this bar right here, that means that this term here is divisible by that term. So then you're looking at symmetric. And so for symmetric, your symmetric is, think about it, X, R, Y, R, X, right? And since you're looking at this term being equal to 0, more or less here, then you got X squared minus Y squared. Well, you slap a negative sign in there, and then you can then reverse it to get Y squared minus X squared. So Y and X reverse each other, because you're looking at this, and down here they do it a little clearer. This term's equal to 0 ultimately. And so then 0 is divisible by 5. And if you flip those around, if it's equal to 0, you can add a negative sign in there. And then for transitive, you're just going to basically add a third variable in there. So if you're dealing with L, M, N, P, you could use P, whatever you want. It's just a letter. So then you've got the relation between X and Y, and then link the Y and Z. So M and N and P, if you're using M and P. And then you just follow the arithmetic. You're just doubling up. You're adding a third one in there, writing the same notation as this divisible by 5. Then you see that the Y's cancel out. You're left with Z. That just because the letter changes doesn't mean it's not in the same set following the same exact thing. So it is transitive. So if you don't understand all of this, it just takes time to process it. You have to think about it. You have to do many problems. It's been a long time since I've done this course. I'm going through the calculus bank, and this was in the calculus question bank. And it's technically, it could be considered calculus if you're in a theoretical concepts of calculus course, but more or less it's a real analysis or abstract algebra or modern algebra question. So most of the time, you can find these solutions all online everywhere now. You don't have to post questions constantly for these things. They're everywhere. You just got to know how to read them. But if you don't have the book, if you're not reading the book definitions, you're going to be in trouble. So keep that in mind as you progress through the course. Have a great semester.